Our goal here is to make a chart explaining the concavity of this function and to justify any points of inflection that occur in their x values. So, first thing we do is we're going to take the first derivative, get 3x squared minus 12x by our power rule. And then now we have to take the second derivative because that's the function that tells us about concavity. So we get 6x minus 12. So then our points of inflection are going to occur when the second derivative is equal to 0. So we know that this is equal to 0. 6x plus minus 12 is equal to 0 at x equals 2. Okay, so we're going to make our chart. So the change happens at negative 2, so we're going to go negative infinity until 2, and then we're going to go 2 to infinity. Okay, so we have f double prime, and then we can talk about f prime, magic, I just moved it over here so I can fit in f, which is super important. Okay, so remember that f double prime is equal to 6x minus 12. There's a couple ways we can think about this. We can think about the fact that this is a line that is sloping upwards, so it looks like this as you follow my pointer, which means it's going to start negative, it's going to cross through at x equals 2 and go positive. But another good thing to do is to test points. So we could plug in a point in our interval, negative infinity to 2. That's awesome. I can pick 0, right? F double prime 0. So I can see that 6 times 0 minus 12 is going to be negative. So that's all I'm worried about. I'm just worried about whether it's negative or positive. So I see it's negative, and then at 2 it's going to cross over and go positive. So that means that f prime x is decreasing from negative infinity to 2, and it's increasing from 2 to infinity. And so negative means that f of x, a negative f double prime, a decreasing f prime means that f of x is going to be concave down. Concave down, that's a frown. And then positive f double prime, and increasing f prime means that f is going to be increasing. So then we can say that we have a point of inflection at x equals 2. So we'll say POI, we'll write out our justification here, POI at x equals 2 because, it's a great little B there, because f double prime switches from negative to positive. We just need to say it switches signs, so negative to positive. Switches from concave down to concave up. So we know that our graph is going to be concave down here and then concave up here.